Hello and welcome to this week's Productivity Enhancer. Last week we took a look at the Simulation Express tools in SolidWorks 2013, and that is a SolidWorks Premium add-on. However, we're going to take a look at a feature that is available to all SolidWorks users from Standard on up to Premium, and that is the FloXpress tool. What the FloXpress tool does is it will analyze how liquids or gases will flow through a specific part and see if there's any stagnation in the flow or whether a port needs to be modified to accommodate a certain pressure. You may think that the FloXpress tool is not all that powerful or won't have any applications for you. However, it's a really quick and easy way to set up a flow analysis so you can make any necessary modifications if anything jumps off the part at you. In order to use the FloXpress tool, you must have an inlet and you must have an outlet, or there'll be nowhere for your liquid or gas to flow. So let's go ahead and take a look at our part. So we have this shelled structure. You can see that we have a hole on either side, and in fact, let's go ahead and make this transparent right now, just by going under the appearance, and we'll just make it a little bit lighter. How about there? And now you can see inside of our part. So we have the inlet, which is the small hole, and our gas or liquid enters in that hole, makes its way through this grate right in the center, and eventually makes it out the outlet here. And next, before we run our flow analysis, we're going to have to cap off these holes with lids. And the reason for that is that SolidWorks is going to need a surface or something to register the pressure that's going to be flowing through this hole. So by putting lids on these holes and not merging the results, we'll have something for that pressure to push against to get a good gauge. So let's go ahead and find those sketches. In split line 1 and 2, you can see we have either sketch. Sketch 2 is the outlet hole. Sketch 3 is the inlet hole here. So let's just go ahead and extrude out this sketch. Let's just make it 1 millimeter and reverse it so it goes inside. Oh, it was already going in. There we go. And the thickness here doesn't really matter. This part is shelled out to be 4 millimeters thick. So as you can see, our 1 millimeter thick lid isn't flush with the inside surface, but that's okay. So let's just accept that. And then let's get sketch 3 with an extruded base and make sure it's going the right way. We'll reverse the direction so it's facing inside and click OK. So there, now we have our lids. And now we're ready to run that FloXpress analysis. So we go under Tools, and you can see right here, FloXpress. And the first thing you see is this massive message here. And what it does is it tells you a little bit about the FloXpress tool, and it tells you that you also need to have lids in order for the FloXpress tool to work. And it also gives you a disclaimer saying, do not rely solely on the FloXpress results. And that's basically just to cover their tracks, because honestly, this isn't a very detailed analysis. This is just a way to get a really good top-level analysis. And if you see that certain things aren't quite making sense or working out the way you anticipated, then you can go ahead and make design changes based on that top-level analysis. However, we have lids, everything's good to go, so let's just click Next. And here you can see the geometry is okay. Click View Fluid Volume to display the fluid volume on your model. So let's go ahead and do that. And you can see everything in blue here is the volume inside of that shelled part. You can see this little bridge here, that's where that vent is. So those open spaces will be part of the volume of this part. We can also see that the volume is 42.084 millimeters. And this is here is mostly for your reference. So let's just click Next. And one of the limitations of the FloXpress tool is that we're limited to either water or air. And if we do change to air, you can see changing this parameter requires recalculation from the beginning. I do not want to change that, so we'll leave it at water and click Next. So our message says in this step, assign flow condition to your model's inlet. And what that's asking is, do you want the flow condition to be based on pressure, volume flow rate, or mass flow rate? I'm going to go ahead and select mass flow rate and click Yes. And then I'm going to choose the back face of the lid that we created on the inlet. So I'm going to right click, select Other, and I'm fairly sure it's this face here, but let's zoom in and take a look. And let's go ahead and bump this mass up. How about just to 1 kilogram per second? And click Next. And now we need to find the outlet. In the step assign flow condition at the model's outlet is what the message says. So let's find that face there. That looks good. And for this flow condition, we do want pressure, and we're just going to leave it at atmospheric pressure right there. So we will click Next, and then we can solve it. And now SolidWorks will run the analysis. And instead of making you watch the green bar go painfully across the screen, I'll cut to the end. My system is pretty fast, and it still took a little under a minute just to generate these results, so you can expect a little bit of time. However, when we take a look at our part, you can see that we have all kinds of information here having to do with the flow of water coming from the inlet, and you can see most of it swirls around and then goes through the vent here and then out the outlet. The color of each one of these pipes corresponds to the velocity of the water coming through the hole. So you can see it comes in hot through the inlet and slows down around the curve, and then it speeds back up when it goes back into the current. And all of this business over here is really slow. That's almost at 0, so that's showing some stagnation there. And then it speeds up as it goes out the outlet. If you'd like to see an animation of the trajectories, you can always hit play, and that will generate for you. There you go. And we can also change that to balls if you'd like a little more molecular feel. And when we run that animation, you can see it's flowing just the same. We can plot it from the inlet, which it is right now, or the outlet. And we can play with this slider here to manipulate the number of trajectories. So let's change this back to pipes, and let's get a nice full-on view of this and take a picture. Right here you see a snap image. We can snap that image, and that image will show up in the report. But let's take a few. Let's take one right at the inlet, and then we'll take one of the outlet as well. And then when we generate that report, SolidWorks will generate a Word document with the report and these photos as well. So if we go down and pull that up, you can see we have document number 1 with the SolidWorks FloXpress report. This first paragraph says that the FloXpress is not the be-all, end-all analysis tool, and it shows you how to upgrade. However, the information for this report all shows up right here. We can scroll down, and we get those pictures stacked up so we can see everything that we need to see. So once again, the FloXpress tool does have its limits. However, it's a really great quick analysis tool that allows you to set up a really quick flow analysis that'll give you an idea of any design changes that you need to make in order to achieve your original intent. So thanks for watching this week's Productivity Enhancer. Until next time.